Hello everyone, this is Samir from Audio Science Review. I have a product review for you, a very high-end DAC from a company called Chord. It's the Chord DAVE. You see it on the right side over here, and the box itself is sitting there on this thing. It's a very expensive DAC by most standards, $14,000 for the stereo DAC, although DAC prices can go up to $60,000, $70,000, believe it or not. Anyway, there's been a lot of requests to measure this, and I was fortunate enough to connect with a member that had it, and he was kind enough to send it to me for review. As you can imagine, sending something this expensive to someone to be tested, there's some risk involved, and I really appreciate the member sending it in. I really dislike the user interface on other Chord products. They have these glow bubbles that change colors, and you have to, keep looking at the manual to know what's what. And even then, you may mistakenly think you have the DAC in one setting versus the other. So I was really looking forward to this higher-end product from them that has a display on it. And while the display helps a lot, now you can see that USB input is USB input, and you see the volume and everything. Still, I found it quite hard to navigate. It's got 4 buttons in here, plus a push-enabled rotary controller for the volume. The volume is fine, more or less. This is a slippery metal globe, and it almost has enough room for your thumb to change it from top. It just feels too small and slippery to try to change volume on it. But, it works. What doesn't work is this constantly remembering, how to go change these settings in here with 4 different buttons, which one goes to which. And some of the modes, at least one of the modes, requires pushing these 2 simultaneously without touching something else. It just seems like a company that doesn't believe in any usability studies. They should put a person, in front of it and just tell them to do simple tasks to see if they can figure out how to do it. A DAC shouldn't be a complicated device to turn on and use and change the settings. And there are companies with just 2 buttons and a rotary control that do a far better job than Chord does. This display is also slanted back, as you can see from this unit over here. And which means if you put it on any kind of shelf and sit back in a home 2-channel listening space, you won't see anything of this display. It loses contrast tremendously as it goes slanted normally, and you barely can see the USB and the volume control. All of these get washed out completely. So the company itself sells this $2,400 stand to tilt it and everything. Or you can use it, I guess, on a desktop on this thing. So I like the nautical look of it with this circular dial in here and the rest of it, no objection. But bottom line is, can you get in, get out of using a simple device like a DAC? And I don't think that's the case in here. It is quite heavy. It weighs 4 kilograms or 8 or 9 pounds, and it feels that when you pick it up, you almost have to use 2 hands to pick it up on that. So normally, just a quick caveat, normally when I measure products, I don't take their price into consideration because, some people can afford to pay a lot more for an audio product and, for look and everything else. But in this case, the DAC is very, very expensive, and the designer has this seminars left and right, talks about all the precision and perfection of this DAC that is better than any other DAC out there. So just note that I will be picky as a result, given the marketing claims on this thing and the price. So as usual, we run our 1 kilohertz dashboard. The Chord DAC can be put in the DAC mode or preamp mode. And the only difference is that in DAC mode, the output is fixed voltage. In the preamp mode, it's the same thing, but you can adjust the volume. So when you just put in DAC mode, it puts out this oddball 6.2 volts. I don't know where they get this from. The standard is 4 volts for a balanced output. 6 volts may or may not overflow the downstream device. If you're going to pick a fixed output, just pick 4 volts, not some oddball 6 volts. But this is typical of Chord products. They all have this kind of quirk in them. It helps them in an A/B test. If you compare this to another DAC that has only 4 volts output, this has 6 volts, going to sound louder. People might prefer that. So anyway, getting into the measurements, this is our 1 kilohertz tone. This is our second harmonic. We see that the two channels are very different. The blue channel versus red channel. The red channel has a lot more second harmonic distortion. But something that you can't see in here is that this noise floor was just dancing up and down, and then it would go back to zero and dance up and down and go back down. And this sinad, I'll show you in a minute, was jumping all over the place, but only in channel 2. But channel 1 more or less was good. And to show you that, I can't show you the dancing around, but I went ahead and recorded the sinad output, sinad measurement for the DAC in the two channels. And you can see that the blue channel is going along fine, but the red channel is like all over the place in here, as much as 6 dB variation in there. It's still good at 107 dB, so it's not something you're probably going to hear audibly, but, you know, definitely blows any argument about precision and greatness of the design. There are 2 other measurements out there of this DAC, and they don't show this. They don't have this exact measurement, and it's possible that they saw it and didn't plot it, didn't pay attention. I don't know. I can't speak for them, but I'll leave the door ever so slightly ajar that this unit is, you know, just something about this design or degradate, it's degraded, or manufacturing's got a problem. Either way, if the company thinks this is not representative, they can send me another one and I'll measure it. I'd like that to be a random sample from a dealer, not one that they would handpick to send to me. But anyway, very disappointing right out the gate to have one channel do this. You know, I went back to verify this was not a problem with our measurement. I have a topping D70S next to me that I use for this kind of quick test. And its sinad is 119 dB and rock solid on both channels. So exact same cables were used, from power cables to interconnect to analyzer. Nothing was changed other than just moving the wires from that to this, and results were perfect. So it's not an instrumentation problem on this thing. I often see this kind of problem with DACs that pick up noise over USB. This DAC claims to have galvanic isolation, meaning that even noise polluting the ground should not matter. But I figured I'd test that possibility by not using USB, but going with an optical toslink. Now we have full electrical isolation, and we're not even using USB. A USB cable was unplugged. And I was disappointed to see the same modulating, going up and down, continuously. Here I've got this adjusted to minus 4 dB, FS, this 0 should say minus, to get us 4 volts to be able to compare it to other DACs. And so if we go back to USB input, we see the same result again with the same noise modulation. Now the sinad, you can see one of the instances where I snapshot this picture where the second channel is dropped out to 108. For average these two, you know, the DAC lands in this blue quartile that I call excellent, but boy, for 14,000, it better be pegging the max over here, not be worse than probably, what, 30, 40 DACs are performing better than it on this thing. And the sinad is the same as Chord Mojo 2, which costs a fraction of the price of this unit. So even if we forget about the modulation for a second and say this is a, you know, sample problem, overall performance is not good. And this, by the way, is consistent with measurements others have made as far as the sinad. They get 112, 114 dB. So best in class is 123 dB. 123 dB. So we're way, way, way off from top of the line performance as far as noise and distortion. Again, the company raves about caring about the utmost detail in their signal processing and noise modulation and everything. So we can certainly hold their feet to the fire in here and say, look, if you cared and left no stone unturned, you should be way up here, not have this much noise and distortion that pulls your performance down on this thing. It appears that the internal design is unbalanced, that there's a kind of conversion to balance that actually has a penalty. So because the RCA output is actually a little bit cleaner, it still modulates up and down, so that problem doesn't go away. And we can once again see that it's got this oddball output of 3.1 volt rather than 2 volts. So again, take caution if you're doing a listening test, comparing this DAC to another DAC. By far, 95% of DACs I test put out 2 volts on over RCA, not 3.16. To get close, go down 4 dB on the volume control, and you get more or less 2 volts that you can then compare. Do not compare it with the fixed volume. It's a capable DAC as far as output. It can actually go beyond what I even showed you and goes as high as almost 11 volts in here before it clips. It clips really, really bad. You get a nasty square wave with modulation at both ends of it. So do not go into the clipping mode, and don't go past plus 3 dB. And on the volume control, it goes all the way up to plus 9 or 10 or something, 11. But don't go past 3. Anything past 3 dB means it will clip, and will clip really bad. So stay out of that, and performance more or less doesn't change anyway. So on this thing, and the only reason to use higher output is because you have an amplifier that has a low gain, and it performs with a lower gain. Like the benchmark HP2 DAC, amplifier. For that, you do gain something. So it's nice to have that extra headroom in there. I went ahead and ran intermodulation test versus level. And this graph, when it's sloping down, is noise dominated, and then at the end it becomes distortion dominated. We see that its performance is the same as one of my references, which is a Top-In DX3 Pro. This is a 3-year-old DAC, long obsoleted, and yet has the same noise figure as it's $250 at the time. And yet this $14,000 DAC doesn't better it in noise. It only betters it in distortion when you go at the maximum level, then we have a gap in here. I ran a multi-tone test. In this critical area, it does very well, 21 bits. Best in class does 22, 23 bits, but 21 bits is certainly very good. But it's got this strange intermodulation tones at very low frequencies. I don't know what's causing that. It could be power supply noise or who knows. But otherwise, it's very good. This drops it down to only 17 bits of resolution, which is nothing to write home about. This linearity graph, the ideal is a flat line, and this looks almost like a flat line, but if you pay attention, you see that it's sort of wiggly way down here till you get here. Even a $150 well-performing DAC will be almost ruler flat and not have this wiggliness in here. So I think this is only good to about 18 bits and not above that, so which is just not competitive. It should be at least 20 bits, and if not more. I've talked a lot about noise. Let's actually measure it, and this is the RCA out. We get 113 dB, 112 dB. That's 19 bits of dynamic range before noise takes over. It's not competitive. I'll show you in a second. And this is the XLR output. This is almost the same. But to show you a comparison, this is the Mola Mola Tambeki DAC. Which is priced similarly to it, but it's also a streamer. Look at its performance. It's also a custom single-bit DAC, just like this one is. So it's not built on off-the-shelf chips. And look at it, there's 122 dB in here, and we only have 113 in here. That's a massive amount of noise difference. And noise is something you hear. It's just a matter of how far you turn up the gain on an amplifier, or how sensitive your headphones are if you're doing headphone listening. Distortion you may not be able to hear, but noise you will hear. So in this critical area, performance just not there. And is it audibly transparent to everybody? Yeah, this is about threshold of hearing. And so I don't expect anybody else who's listened to it say, oh, it was very noisy. But, company again talks a lot about measurements, and we're not seeing that. The main thing they talk about tremendously is this reconstruction filter that they have, and how they use, I think, 160,000 taps in there. And the more taps they use, the more sharp this gets, the more of the audible band it preserves, and the less of the outer band that it lets through. But this kind of performance above 20 kilohertz is obviously, most of us can't hear 20 kilohertz, let alone above that. So getting that to be more and more vertical, I take it, give it to me. It is engineering excellence, but it's not an audible excellence. But, job is well done in that case, and attenuation is very good for out-of-band area. It has a mysterious high-frequency filter that's not documented, so I had to Google for it, and secondhand information was that it should be left on normally when you use it, but if you use their M-scaler resampler, you turn it off, which is very strange, because if you leave this on, you get a roll-off that actually starts around 2 or 3 kilohertz, and by the time you get to the to 20 kilohertz, you've lost almost 1 dB. Why on earth have this sharp filter and in one breath, and in the next breath recommend that people have a slow filter added to it that chops off the response? Fortunately, you can turn it off, and if you turn it off, you do get ruler flat response now to 22 kilohertz, or that the bandwidth of this measurement is at 44 kilohertz sampling. But maybe that's why they don't document it. It's just impossible to justify, you know, like I said, needing a sharp filter and then cascading with it a slow roll-off filter. Slow, relatively speaking. So not good. Performance, you know, I've shown you a lot of stuff at 1 kilohertz. Now we run a test that sweeps from 20 kilohertz on down to 20 hertz. We get a flat response, which is good. That means it has no frequency dependency. But this line should be way down here. State-of-the-art DACs are around this 0.03. And because it's got extra noise compared to state-of-the-art, is actually landing up here. This is a $99 3 or 4 year old DAC. And, you know, it's almost the same as far as noise in this critical area. So definitely not competitive. So those are the DAC measurements. It's got a headphone output, and I believe a lot of people buy this as a desktop headphone app and DAC. So let's measure that. One measurement I perform is that I lower the volume till it's only 50 millivolts out there, simulating a reasonable volume on a very sensitive in-ear monitor headphone. And when I do that with this DAC, I get a number of 82 dB, which is only 13.5 bits dynamic range. So worse than the CD format that you're listening to. And if I put that in context of all the other DACs I've tested, DAC amps that I've tested, you can see that state-of-the-art is over here around 95. Here we're down at 82. So slightly above average, but you know, not suitable for listening with sensitive EMs, because you know, you might hear the hiss and noise from this DAC at high volumes. So, you know, anything below 90 is just not good at any price. To have it be a $14,000 amplifier in a DAC, it's just not good. You measure the output. I was surprised how jagged it is. Okay, one channel of it may be the DAC problems I talked about, but both of them have this hump in here, then they go down, and it's just messy response. Look at the competitors that I've tested. Again, that same topping DX3 Pro, which is a $250 DAC. Look at how predictable and ruler flat they are. It's nothing wiggly and weird is happening to them, but this one is just all over the place, likely because the noise profile is changing depending on what it's doing. It almost gets to 100 milliwatts, which is my minimum standard for any desktop products. And once you have 100 milliwatts, you can get reasonably good volume out of a, let's say, Sennheiser HD65X type of products, headphones. This one barely gets there at 98. You know, for this price, I expect it to be 400 or 500 milliwatts. So you can drive a wider set of headphones than just the minimum standard. And similar story, you know, same wiggliness if we change the impedance to just 33 ohm, and we see the same wiggliness. The good news is that its distortion sinks way down before it clips at 1 watt. So as long as you stay below that nasty clippiness, you do have a very low distortion device at these higher volumes. Finally, I have a test where I changed the load from 12 ohm all the way up to 600 ohms. And ideally, all of these graphs would land on top of each other, but they rarely do, meaning that as you decrease the impedance, you're stressing the DAC more and more, and its voltage starts to drop and its distortion starts to increase. But in grand scheme of things, this is not a concern on this thing, other than just low output voltage of just 5 volts. Now, I know some of the folks looking at this video say, wow, your measurements mean nothing. All I care about listening test. So I spent a good bit of time listening. I know Rob Watts that designed this this product, loves the Dan Clark Stealth headphone, which I also own. So I did listening tests with that. At low to medium volumes, it sounded excellent. Did it sound any different than any other DAC? No, absolutely not. I listened to the same tracks all the time, and with countless other amplifiers and DACs, and I detected nothing magic popped out of it. But if you did turn up the volume, the sound would initially get congested, where you couldn't tell the instruments apart as well, and then quickly become shrill and sharp sounding in a really nasty way, meaning that the amplifier is entering its clip-in region and it simply can't drive it. This is a tough to drive headphone. You need a proper headphone amplifier for it to drive it at high volumes, and Chord DAVE is not it. So if you insist on using Chord DAVE with this headphone, I suggest getting an external amplifier like a Topping A90 or something like that will run circles around this. And indeed, I tested it with the Topping A90 discrete, and I could get to much higher volumes with great clarity, with zero brightness increase, and typical of when you crank the volume, actually sound improves, the fidelity improves, the dynamic range improves. So much more enjoyable, but be careful, you could damage your hearing. I then switched to the Sennheiser HD650, which is a high impedance headphone. I saw the same problem. Again, at low to medium volume, it sounded fine, sounded good, just, as good as I expect the sound to be, but crank it up and it gets shrill really bad. This was without EQ for the HD650, and so it doesn't have as much bass, so the high frequency sharpness was there and really, really bothersome to me. So people say this sounds great. I don't know what their reference is. I don't know how they're doing their testing. I don't know what their hearing acuity is. They can't hear the shrillness and brightness, and it's absolutely there, and it's backed by measurements that this amp is going to clip in a very ugly way, and it runs out of power. But below that, hey, it's a great sounding DAC, and I detected nothing that was a problem when the headphone amp wasn't running out of power. So where are we on this thing? The company has this tagline, says DAVE stands for Digital to Analog Veritas in Extremis. This extreme in truthfulness. Well, it is not extreme in truthfulness. To get to extreme truthfulness, you need to buy a product that has the least amount of noise and distortion, and those fortunately cost $500 or $600. So what it costs to ship this product to me, probably if I bought it, you could buy a product that truly, objectively, provably is there, and absolutely in sound quality. You can listen to them, and those other DACs are absolutely tremendous. Pair them up with a great amplifier for another $400 or $500, and you have world-class sound at $1,000. So, if you're paying $14,000 for this unit, know that you need an external headphone amp, or if you're using it with speakers, know that you got to screw around with tilting it or something so you can see what the heck it's doing far away. So I went into this review expecting to find a hugely performant DAC, over-designed and expensive. I expected it to be perfect or near perfect. Unfortunately, what I found was what a $150 product would produce, and from DAC section and maybe a $100 amplifier. I think a lot of $100 amplifiers, headphone amps, will outperform it. So I just don't understand this. The company clearly has an audio precision analyzer. The designer knows how to use it. But, go look at their website and you see none of the measurements that I just showed you. They have a few spec numbers. They're all A-weighted, which means that a massive roll-off in low frequencies is applied, filtered before measuring it, and that would actually eliminate that noise modulation that I was showing you, because it was showing the most in the low frequencies. And so if you put a high-pass filter in there, and like a A-weighting is, you're not going to see that on this thing. So, if a company wants to object to this, I challenge them to run all these things. I'm happy to give them the project file so they can replicate what I have one for one. Let's see if we get better results. As I mentioned, there are other reviews with that find similar performance. They, of course, brush it under the rug and, say this is the best thing since sliced bread. I do not, I can't hide, what you see is what you get, and I have to treat every product the same. So there's just no way I can recommend this product. Very disappointing. The company needs to go back to the drawing board and just run these simple tests and go in the design and clean it up. There's no reason any of this is fundamental to the design of the product. These things could be fixed, but clearly they have, and the company has been so successful with its marketing of using techno buzzwords that they haven't felt the pressure to redesign. but they're just not competitive at any price. So disappointed. Okay, see you in a future review. Bye-bye.